Hello all, welcome back to my YouTube channel Rapid Data Tracks with Shubha. So let's dive into one more foundational topic of big data, that is Hadoop and its architecture. Okay, so let us understand what is Hadoop. Hadoop is a framework that is used to build big data challenges, and it is often called as an ecosystem as it brings many tools and technologies together. And Hadoop has three main components. First is the HDFS, that is Hadoop Distributed File System. Second one is MapReduce. It is used for distributed data processing. Third one is Yarn, that is yet another resource negotiator. It is used for resource management. Now let us understand few tools of Hadoop ecosystem. The first one is Scoop. It is mainly used for data ingestion from external sources to HDFS or vice versa. Although it is useful, nowadays it is considered as outdated. And the second one is Pig. So this is a tool used for data cleaning, but again it is not widely used or recommended anymore. Third one is Uzi. Here this is a workflow scheduler where it chains all the jobs together, but now it is highly replaced by Azure Data Factory, which is our ADF. So moving on to the next one, it is Hive. This is mainly used to query large data sets. And the next thing is HBase. It is treated as a NoSQL database for real-time reads and writes, but in nowadays we are preferring Cosmos DBs for such particular actions. Now let us understand Hadoop's architecture. So here we will be having one name node and multiple data nodes. So these data nodes are by default of size 128 MB. So for example, our file is of 500 MB as shown in the picture. So what I'll do is I will divide this file size divided by 128 MB. So that will approximately come around 4. So it means you require 4 data nodes. So 3 data nodes will be of size 128 MB, and where the fourth data node will be of size 116 MB. So the 4 means the file is divided into 4 blocks. As you can see here, the file is divided into block 1, block 2, block 3 and block 4. So these will be stored in data node 1 to data node 4. So if someone asks you that they require file 1, so name node will be providing them the address of data node 1 to data node 4, where part of the file is present between these nodes. And the next thing is, how will name node get to know that data node 1 to 4 is having file 1? As you can see in the picture, it has the metadata stored in this structured format by making use of rows and columns. So with this, name node can give you the exact address of the file that has been requested. So before moving, I want to introduce one more thing, that is replication factor. So here Hadoop has introduced this to avoid the data loss. As you can see, the block 1 is available in data node 1, 2 and 3. This is because if by mistake the data node fails, then the service should not stop, and the copy of that will be available in data node 2 and data node 3 as well. This replication factor is set by default. If you want to increase or decrease the copies, then you can do it with the help of admin settings. Now imagine, like, obviously the data grows, right? So handling metadata for all of that will become a bottleneck for name node. So you may also have a doubt, like, what if name node fails? So then not to worry more, because Hadoop has something called as name node federation. It will be having one primary node, name node, and many standby name nodes. So these all will be connected to a shared storage to maintain the consistency of data and to ensure the scalability. So by any chance, if the primary name node fails, then immediately the standby name node will take over, and also it ensures the zero downtime. So this is called as name node federation. Okay, coming to the challenges with Hadoop ecosystem. Even though Hadoop is very useful, but it has some limitations too. The first thing is MapReduce. It is very slow when it comes to the performance, and writing the code is a very complex thing. Sometimes even understanding the code also becomes difficult over here, and here the learning curve is too steep because you already saw there were many tools that were available. Each tool for different purpose. For example, one for ingestion, one for your job scheduling, one for your data cleaning. So in this way it becomes overwhelming. And the next thing is, Hadoop is meant for on premises, so it makes it less flexible for the cloud native solutions. So these are few things that comes as an disadvantage of the Hadoop ecosystem. So this was a complete overview of Hadoop architecture. I hope you have understood what is Hadoop, why it is called as an ecosystem, and its architecture and as well limitations. So nevertheless, I'll come up with such more amazing content again. Stay tuned for that, and please don't forget to like, share, and subscribe to Rapid Data Tracks with Shobha. Thank you so much for watching. Bye bye.